Hi everyone, this is your assignment on population ecology, the assignment that we would be doing after taking our population ecology notes. A couple of things from those notes just as a reminder that we do have different demographics of populations that we kind of want to keep track of, and that we would be able to use that data, that information to tell a little bit more about a population. So some of the things that we look at are size, maybe density, and the different methods that we would be using to maybe determine size could be the quadrat method or the mark recapture method. So those were a couple that we talked about, also electronic tracking in those notes. We're going to focus on the quadrat method here first for this lab. Or this activity, this assignment for the first part of it here. Question number 1 says to give an example of an organism, random sampling or quadrat method. So remember, if we look at our notes from population ecology, that's slow moving or immobile organisms. Some sort of a plant, something that can't get up and walk around, and we would just look at an area, a given area, and pick that given area and go ahead and count the population within that area. So these could be things like morel mushrooms, they could be things like different shrubs, maybe a specific type of tree, that kind of thing. But we would just kind of stake out that area and go ahead and count the population. So any of those, any example would work here if it is slow moving or immobile completely. That being said, another kind of a way to look at this, we're going to look at this example here. We have a biologist that collected 50 liters of pond water and counted 10 mosquito larvae. And we want to know how many larvae would you estimate to be in the pond if the total volume was 80,000 liters. So larvae are not going to be moving very quickly. They have not hatched yet, so they're pretty slow moving. Or immobile, I suppose you could say too. So we're going to look at that population in the water. And the way that we're going to do this is we need to look at what we gathered and what we are trying to figure out from there. We know that within 50 liters of pond water, we found 10 mosquito larvae. And I'm just going to abbreviate that with MOSQ. So for 50 liters of water, we found 10 larvae. And if we do the math on this, that would equate to 0.2 mosquitoes per liter. I'm going to do MOS. Per liter of water is what we would find in that sample. But we don't want to know how many larvae are in just that sample. We want to use this to help us estimate, well, take into account there's 80,000 liters of water in that pond. Now, how many mosquitoes would we estimate to be there? So this right here is essentially our starting point, telling us that the number of larvae total, because remember in our ecology notes, our population ecology notes, N stands for the total number of individuals. So the total number of individuals, which is what we're trying to solve for, is going to be equal to this ratio of 0.2 mosquitoes per liter times a total of 80,000 liters. And you can imagine this is 80,000 liters over 1, if that helps you to understand that. But eventually, when we do the math, the liters would cancel out, leaving us with just the number of mosquitoes, which is what we're trying to find anyway. So when we do this math, 0.2 times 80,000 liters, we get 16,000 mosquitoes. So just using very simple math that we learned in physical science when we were doing sample calculations, looking at what do we know? We know that we had 10 mosquitoes for 50 liters. which gives us this ratio of 0.2 mosquitoes per liter. Again, this is just not an estimate, but it is an estimate because this is only a small sample of that. But if that holds true for the other 80,000 liters, then we would expect to see 16,000 mosquito larvae in that 80,000 liter pond. This does pose some problems because when you think about this, if we're just looking at a small area that we staked out, this small area being 50 liters of pond water, that's great for that 50 liters of pond water, but it's just one sample. So a couple of things that you need to think about is that we're not sampling enough. And when we don't sample enough, that kind of means that we're not really understanding the population distribution. So one of those problems, again, is that we're just not sampling enough, and we're showing that we're failing to understand the population distribution. I'd write all of that out there. The other thing is that we're sampling during a time when there's no reproduction occurring, or immediately after a season that produces offspring. So these numbers could very well be drastically different based on those two different incidences or two different occurrences happening. But that's quadrant method. So just to give you a review about that. Now what we're going to actually do is we're going to collect some data on the mark and recapture technique. This is the lab part. So if you're gone from class today, this is how you would be doing this in class today. You would collect a population bag from the front counter from your teacher. And here's our population bag. It's population H. So it says to record the bag's ID letter here. So we're going to just write H. And it says each bag contains a population of animals represented by beads, both clear and red. So just to show you guys, there are red beads and there are clear beads inside of the bag. 10 animals have been marked and returned to the environment represented by the red beads. So inside of the bag, there are 10 red beads in there. Those are our marked populations, or our marked animals that we have there. What do we mean by this? Well, again, if we go back to our notes 3 population ecology notes, the mark recapture method is what we use when we are trying to determine population size when we're working with species that move. So we capture a sample of those species, we mark them either with a tag, a band, some sort of paint or some other body marking, and then we release them back out, and then later on we would capture a new sample, and in that new sample that we recapture, some of them are recaptured, meaning that we've already marked them, but then some of them are new and they hadn't been marked yet. And then from there, we would determine the ratio between the marked and the unmarked animals or organisms that we were able to grab or contain. So it says, without looking, use a scoop to recapture animals in the population. Record the total number of animals recaptured and marked in the data table. So this is the total of the clear and the red beads that we're going to take out each time. This is the total of just the red beads that we take out each time. And we're going to use these numbers to do our math over here. So the first one, I'm just going to take some beads out of the bag. Okay, and then we're going to count all of the beads here. So I'm going to just move them over and we'll count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 clear beads and red beads. There are no red beads, so 14, and then I would say 0 red beads only. Okay, so that's how many of my population that I was able to recapture or capture the first time, and then I would tag them and I would send them back out. But these have already had some tagged, so we're just gonna kind of imagine that that's the case. Okay, next one, we're gonna do it again. Oh, we've got a red one in here this time. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 clear and 1 red. So that's a total of 11 with 1 marked one. All right, now we go back in. We're gonna go try to capture some more of these animals. We're gonna get another sampling here. Okay, no red ones again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, back in the bag. So we're gonna do this for a total of 10 times to get a good sampling, a good amount of data here. Ooh, 2 red ones this time. 1, 2, that's not working. 1, 2, 3, 4, 5, 6, 7, 8 clear and 2 red. So that's a total of 10. And we'll put 2 down here. And then we would mark them or tag them, release them back into the wild. We'll get another sample. Oh my gosh, 2, 4, 6, 8, 10, 12, 14, all clear, no tagged. Does this happen in real life? Absolutely. Okay, another sampling. 2, 4, 6, 8, 10, 11, a total of 12. And one of those is a red bead. Do it again. Oh my gosh, look at that. 2, 4, 6, 8, 10, 12, 13 clear, no red. Ooh, 3 red this time. Okay, 2, 4, 6, 8, 10, 11 clear and 3 red. So that's a total of 14 with the 3 red there. 2 more times. And I promise you I'm not looking in the bag, tilting the bag so you guys can see the bag. And I'm not looking in the bag. Oh, another red one. All right, 2, whoops, well, that looks like 3 now. 5, 7, 9, 11, and 12. With one of those being a red bead. And the last one. Oh, that wasn't enough. Hold on, let's do that again. Okay, that's better. Better population. Okay, 2, 4, 6, 8, 10, 12, 13 clear, and 2 red for a total of 15 and 2. So now what we're gonna do next, there's a little bit of math involved, but again, it's very simple math, kind of like what we did up above. Nothing too crazy here. You're gonna add all of these beads, the total, grand total for this whole column, and that number goes in here. You're gonna add these beads, and that grand total goes in here. Then we're gonna use these totals in this equation right here for our next part of this. So let me zoom in a little bit so you can see what that looks like. It says estimate the population size N by taking the total captured, which was this number here, so total captured goes here, multiply it by 10, divided by the total captured with the mark, divided by this number that you got here from this box. So the complete total from the first column, the left column, multiply that number by 10 first. Then, after you've done that, divide it by the number of just the red beads, the total number of red beads, and that will give you your N. And then I can tell you whether or not you're on the right track when you get back to class or when you turn this in. But the population here, so it says for population H, you would write population is equal to the number of individuals. That population H is equal to the actual number of individuals. I can give you this number when you get back to class. I don't want to give any spoilers out for that one. And then after you do that, you'll just need to quickly do this part, the next couple of questions before you continue on. Actually, spoiler alert, the number of individuals for population H is 137. I'm just not going to write it down so you can copy or listen and write it. So you would write H here for population H, that's the bag that we had, and this would be the number of individuals that there actually were in there were 137. So we'll see how close we got by adding those numbers up. And then number 6 means, or says, to compare this actual size that I just told you to this estimated size that you found here. Were we over or underestimating, and calculate the percent error, show your work. So for this one, what you would do is the percent error is equal to the estimated amount, which was this number that you found up here, minus the actual amount, this number that I gave you here. So subtract those first in your calculator, then divide it by the actual amount, which is right here, and that's your percent error. From here, you should be able to finish the rest of this assignment using your population ecology notes. So here again, a little bit of easy math, very similar to what we just did here. Very similar to what we just did here. So look at the math that you did here, and that's how you would work on this problem here. We are going to be analyzing some graphs. We know that this is a very big part of our ISATs for science ISATs next year, so it's important that we continue to work with these graphs and understanding what they're showing us. By all means, use your notes to help you. They should help you quite a bit to answer the rest of these questions regarding different graphs with different populations, ecological populations. And same thing on this last page here, a little bit more graphing analysis, and that should be it. We should be good to go. If you have any questions, please make sure that you ask your teacher, and have a great day.